Okay, let's start the lecture. Now, I did mention in the lab on Tuesday that the assignment specification, or the specification for the first assignment, is up on Moodle. I didn't talk through it though. I'm not going to do it now either because I just want to get through the actual lecture. But he can certainly look at it. There's actually two documents. They're both practically the same thing. One is in HTML form, the other is in PDF form. The reason I have two of them is because one of them is for the purpose of our external examiners, but that's just kind of by the way. I will give a kind of a formal overview of the spec in next week's lab, but you really know the headlines of it already. And there are two kind of major parts to the assignment. One is end-to-end testing, and the other is something called continuous integration, which I'm going to cover today. So if you're kind of anxious, and you also know that this assignment is very tightly coupled with the first assignment in web app development too. And I think you also know, because I have mentioned it, that a major part, I suppose, of the assignment for this module is end-to-end testing. So if you're anxious to kind of get up and running on this assignment, you can actually get going straight away. For example, there are parts of the Movies app that you have developed in the labs in the web app development too, which we haven't written any end-to-end tests for so far. In particular, I'm thinking about the movie reviews area and also the upcoming movies. So as I say, if you're anxious to get going on it, you can start looking at those two aspects of the app and writing end-to-end tests for them. And really what you would do is take the end-to-end tests that you have produced from this week's lab in this module and just keep going with it. But I'll give you a fuller kind of outline of the assignment spec next week. Now, today, I want to start talking about this topic here, CI/CD, and I'm going to work my way through these slides. I'm just going to pause for a second in case there are any opening questions. No, okay, just give me 1 sec now. I'm assuming now people can hear me, isn't that right?
Yeah, all good.
Okay. Okay, so today's topic is continuous integration / continuous deployment. They're two different things, although one is a continuation of the other, or it's CI/CD for short. This is another core part of agile software development. The assumption here is that we've got a team of people working on a software development project. That team may not be located in the same physical location, they could be distributed. And each member of that team is developing some part of the application, whether that be a new feature or fixing a bug or extending an existing feature. Everybody is working away busily on whatever they've been tasked with doing. But clearly we need to bring together each person's code or integrate each person's code into the overall application. And we need to do that continuously. And that's kind of in a nutshell what continuous integration is about. But it's not just enough to bring people's code together. We kind of know now, okay, well, obviously what you do is you have a GitHub repository and everybody works off that GitHub repository. So that kind of solves the problem of bringing people's code together. I mean, GitHub wasn't always there. Repositories weren't always there. So in the good old days, you actually had a single person in the team that was responsible for carrying out this integration of team members' individual code into the overall application. But it's not just bringing people's code together. We also have got to make sure that the application in its current state is functioning. And what does that mean? That means we need to test it. And testing now means we need to run our automated tests. So every time somebody adds a piece of code to the overall application, we need to make sure, A, that the overall application kind of compiles as a unit, or transpiles in the case of JavaScript, compiles in the case of Java. That we would kind of often refer to as building the application. And secondly, then, once we've built a version of the application, then we need to run all of our tests to make sure that everything is still functioning. So this is a definition-ish of continuous integration, and it's kind of what I've been outlining there. So just to read it, CI is a software development practice where members of a team integrate their work frequently, and I'm saying there in small brackets daily. It could even be multiple times a day, leading to multiple integrations. So there's integrations happening continuously multiple times a day, because people will finish their task at different times, and they need to be able to integrate their code into the overall application when they are finished. They don't have to wait until the end of the day or the end of the week to do the integration. We want it to happen immediately. So there's multiple integrations per day, and then I'm saying each integration needs to be verified, i.e. it needs to be put through the full suite of tests that have been developed so far, both unit, end-to-end tests. This is kind of an alternative definition, if you like. And the reason we're interested in doing this on a continuous basis is we want to try and maximize the quality of the software that's being produced. In other words, like if somebody submits a piece of code to the application and we run their tests, and the tests fail, then straight away we need to resolve that. So we're always conscious of making sure that we've got that the standard of the software that we have so far is of a high quality. And we need to, and if there are bugs introduced into the application as a result of a single team member contributing some code, then we need to identify that bug as soon as possible and fix it as soon as possible. We don't want these bugs to arise when the application is exposed to the end user. The how and the why then of CI, we know some of this already. We certainly know number one, we need to maintain a single repository. That's fine. We need to automate the build task. Now, build here, kind of, for now, we can say it means compiling all of your source code, or transpiling in the case of JavaScript. Now, I don't know if you remember or not, if I just flip over to VS Code. This is the Movies app that I'm showing you here. And we actually did in the web app development module, he actually built the application. Now, by building, we mean take all of the source code. You see, at the moment, what we do in order to run our application is we run npm start from the command line, and that starts up a development server. And the nice thing about that development server is you can go away and make some change to your source code, and when you hit save, the development server will immediately retranspile the entire application and push an update out to the browser. Now, that's fine when you're in development mode, but clearly that's not satisfactory when you want to go into production mode. By production mode, I mean we make the application available to end users, and end users are actually using it. So what we need to do is we need to build a production version of our application, and you've actually done that already. And when you do it, what you get is, in the case of a React app anyway, is this build folder. And this build folder contains your application. And if I just dig down into this build folder, here's where all the JavaScript is. We can see there are actually two JavaScript files. There's this one here, and there is this one here. This one contains all of our node modules JavaScript code. And this one here contains all of the source code that we wrote. And if I click on this JavaScript file, then believe it or not, this is actually your JavaScript code, or it is JavaScript code. It's obviously, it has been minified and compressed because we like our JavaScript to be as small as possible in terms of the volume, but it is actually valid JavaScript. Equally, this one down here, this just contains all of the node modules code. Okay, so in terms of building a React app, if it's a React app is what we're talking about, then it's pretty straightforward, but it still has to be done. And the Babel tool will do that for us. Similarly, like if we were developing a Java application with multiple Java files, each individual Java file would have to be compiled, and then we would have to bring all of those class files, .class files, together into one jar file, Java archive. This is essentially a kind of an archive. This one here is an archive of a JavaScript code, as is the one down here. So that's what building kind of means in the context of JavaScript, and building in general just means compiling everything into compiling the individual source code files and then bringing the compiled output together into one unit, whether that be a jar file or some other form. But that should be done automatically. It's not that big a deal, really. Everyone commits every day to the overall central repository. I've said that already. We do the build. Oh yeah, the actual building should be done on a separate server. It's not done on one team member's machine. It should be done on a separate server, arguably. And that building, which I'm saying up here, should be automatic. So every time somebody pushes an update to the central repository, what we want to happen is automatically the application is built on a separate server machine. And we keep the builds, okay, we keep the builds fast, you know, for a very large application where you could have, you know, a couple of hundred source code files, then clearly we'd like the build not to take hours, but to take minutes or seconds. In the case of a JavaScript application, one way of trying to speed up the build time is to employ what is called caching. Caching would mean store the node modules somewhere and cache it there, rather than downloading the node modules folders every time you need to do a build. Just download them once, put them in a cache, and then they're easily accessed without having to download them repeatedly. Test the application, said that multiple times. Well, sorry, test the application in a clone of the production environment. Okay, eventually you're going to be deploying your application to some sort of cloud service, and that's how the users access it. When you're in development mode, you still want to be able to deploy the application. Clearly, you're not going to deploy it somewhere where end users can get at it, but you do want to deploy it in an environment that is going to be as close as possible to the production environment. That's what we're getting at here. Number 7, make it easy for everyone to get the latest executable. The executable would be those compressed JS files that I showed you there. Because just to flip back here, you know, in terms of git ignore, we never include these things in what's pushed up to GitHub because these are all generated files. So I guess we should store them somewhere that everybody can get at them and get at the most recent version potentially. Make the process transparent. You know, this should all happen automatically behind the scenes without having somebody responsible for ensuring that it happens. And that really means we need to somehow script this automatic building and automatic running of tests. Why we do it then? Well, I've kind of already alluded to a number of these points. Detect development problems early, find and reduce, remove bugs early. That's fine. Reduce risk of, going over budget or over time. Increase project visibility. By visibility, we'd like to make sure that everybody in the team knows what the outcome of the last build and the last automated tests was. And there are services that allow us to publish that kind of information, which would then be available to everybody in the team. We will see one of them in relation to Cypress actually, maybe later on. Deliver new features. You see, this is kind of the key to it really. Why are we doing all of this stuff continuously every time the user pushes an update to the central repository and rebuilding our application and rerunning tests to make sure everything is still clean? And the reason is this: we want to try and deliver new features to our end users as quickly as possible and get feedback from them as regards improving that feature, rather than the user asking you for feature A, B, and C and coming back to them in 6 months' time and delivering that feature to them. Can we get feature A out to them as quickly as we can, get feedback on that, then move on to feature B, and so on. Improve team cohesion, that's fine. And number 7, I think, is okay as well. This slide is saying much the same thing, really, in a more snazzy kind of way. It's all about getting better, faster, cheaper software. So you can read through that slide yourself. So that's continuous integration. Okay, continuous delivery. Then the CD in CI/CD actually stands for 2 different things. The CD stands for continuous delivery and also stands for continuous deployment. They are 2 slightly different things. They are related, but they are different. And first of all, I'm kind of giving you a definition of continuous delivery here. And I'm saying continuous delivery is the development discipline where you build software, and we know what that means now. Building here does kind of include testing, automated testing in this case, where you build software in such a way that it can be released to production at any time. So in the bad old days of the kind of waterfall approach towards software development, what kind of happened was you did your user requirements analysis with your end user, and then 10 months or a year later is when you came back to them with the application, and it's only then that they could give you feedback as to whether it was really what they wanted or not. But with CI/CD, we'd like to be able to release a new feature in the production version of an application at any time during the development of the application. But I'm emphasizing here is that it can be released. It's not happening automatically. It can be released is suggesting that it's up to the team leader, I suppose, to decide, should we release this new feature to the production version of the application or not? It's a kind of a manual step, if you like. Everything that went before it is automatic. The automatic building, automatic rerunning of tests, all of that is automatic, but then some major team member decides, will we actually release the new version of the application which has the new features or the new bug fixes? Will we release it to production or not? And they make that kind of decision. That's continuous delivery. Continuous deployment is where the release of the new feature of the bug fixes actually happens automatically. There isn't any manual intervention. Now, it's only very advanced software houses that actually employ continuous delivery. What software houses tend to do is they first of all make sure that their continuous integration practices are up to speed. Then they may move on to the whole area of continuous delivery. And when that is satisfactory as a practice, then they might consider continuous deployment as being part of their overall software development process. So it is an incremental, it's an incremental application of all of what I'm talking about here over time. But there are many software houses that employ continuous deployment as part of their software development lifecycle. And the key to software continuous deployment is that every time, what we're now saying is that every time a team member pushes an update to GitHub, that triggers an automatic rebuilding of the entire application. It triggers an automatic rerunning of all of your tests. And if all of those tests pass, that's critical, obviously. If all of the tests pass, then we automatically push an updated version of the application out to the production service, wherever it's hosted, and the end users get to use the updated version of the application straight away. So that's obviously, that may sound like a very crazy or a dangerous practice to employ, but take it from me, there are many software houses that operate in that way. So CD, the how and the why again, and there's a bit of overlap here now, but so by CD, we mean that team was continuously, obviously CD is completely dependent on CI, continuous integration. So the team was continuously integrate new features into the software. That's not so much a how, but it's kind of a consequence of it. We run automated tests. We know we have that already. We deploy the build to the production. Sorry, we deploy the build to a production-like environment first. You know, when we do an automatic build and then we run our automatic tests, the next thing that happens is that we deploy the application not to the production environment, but to an environment that is very close to the production environment, but not accessible to the end users. We often refer to that environment as a staging environment. I'm using that term down here. So a staging environment is where you would deploy your application to, and that environment is only available to the development team. We deploy it there, and typically we would run tests on the application in that staging environment as well. And if all of those tests, then potentially we can deploy to the actual production environment. The why is, again, fairly obvious, and you can read through those. And this is kind of a key one here. It's all about trying to get feedback from the user as quickly as possible as to whether they like a new feature or not, how can it be improved, are there actual bugs in it? Even though we've done a lot of automated testing, there may still be bugs in it, and we'd like to find those as early as possible. This is a visual that I found somewhere on the web. It's okay, it's a good enough kind of visual representation of what we've been talking about. I've been talking about up to now. There are slight differences in the terms used in the visual, but it's good enough. So this is Maria showing you what continuous integration is all about. And it's, you know, you do your build, which I've talked about, then you automatically move on to, well, it's saying specifically here unit tests, but let's just say automatic tests in general are ran against your code. Then automatically your application is deployed to a staging environment, which I was mentioning on the previous slide. So that, as I say, that means deploying it to some sort of cloud service. And after you've deployed it, you run some more tests on the application. This is, they call them, it says acceptance tests here, but that's essentially kind of end-to-end tests. So you might be doing some end-to-end testing here, but you redo them here because you've now actually deployed the application to a hosting service that is very close to the production hosting service. So that's what continuous integration is all about. Continuous delivery then is all of the same plus this extra step here. And the extra step here is where you deploy the application to the production environment. That's what's happening here. But critically, moving from this step to this step, we're saying that is actually a manual operation. The team leader decides, it's they press the button as to whether we deploy the application to the production environment or not, the most recent version of the application. Contrast that with what we're doing here. This is continuous deployment. And the difference between these two is that this step here is automatic. So all of this is really potentially kind of high risk, I suppose you'd say. So it's important that we have metrics that the team leaders can use to decide whether our CI/CD process is good or not. So what software development teams would do is they would identify some key metrics and they would monitor those metrics on a continuous basis. So very simple metrics might be, do our builds work every time? Or are we having lots of build failures? And if so, can we kind of improve on that? So the actual success rate of your builds, that's a very simple metric that the team leader might use to assess whether their continuous integration process is good or not. Alternatively, there may be build failures, but how quickly can we actually fix a build failure? That might be another metric. Or this one here, test total number of static tool errors. We haven't looked at static tools, but you may or may not be aware of, in the case of JavaScript, linting tools. A linting tool is a tool that will analyze your source code and identify poor programming standards being used in your code. So there are lots of tools out there that can actually do that. And they are generically referred to as linting tools. And so part of the build process, the automated build process, might involve not just compiling or transpiling your source code, but also analyzing the source code to see are there any poor programming standards or techniques being used in your source code. And that might cause your build to be flagged as a failed build. And so the volume of errors or deficiencies that a linting tool might find in a source code before it builds it, that might be a valuable metric to keep an eye on. There's also metrics associated with testing, which I didn't mention, even though we've done a lot of automated testing. Like, how do we know our tests are good or not? So there's this notion of line coverage that is a very valuable metric. Maybe I'll talk about it at some other stage with you. And so what a software development team would do is they would identify a subset of metrics some of which I've mentioned in the previous slide, and they would monitor those metrics across all the various executions of your continuous integration / continuous deployment flow. And the purpose, of course, of all of this is to try and improve the success rate of your continuous integration, continuous deployment process. Now, that's all kind of theory. How do we actually do this continuous integration, continuous deployment stuff that I've been talking about? There are lots of services out there that will allow us to do this. One of them is called Git Lab, and that's the one that we're going to use in next week's lab. So as its name kind of suggests, Git Lab is a Git-based hosting service. Essentially, kind of, it's like GitHub with lots of other bells and whistles thrown into it, but it is a Git-based hosting and collaboration platform. It's open source, that's fine. It's a free service. You could actually run Git Lab on your own kind of in-house server, which we won't be doing, but some software houses would. We'll use the hosted free form of it. And in the graphic here, I'm showing you all of the different parts that make up this Git Lab platform. Now, at the center of it, it's just a Git repository. So this green box is very like what GitHub does for us. So Git Lab is an alternative to GitHub. GitHub, as you may know, it does more than just acts as a repository. It does actually allow you to have user management to manage the different people that can access a particular repository. GitHub also has an issue tracking or an issue recording aspect to it. We're not really interested in these, to be honest, in relation to GitLab, but they are there in GitHub, and GitLab has them as well. Over here, I'm talking about issue tracking. I'm not sure what that one is. This is the part of GitLab that we are particularly interested in. We're going to be using these two parts here of GitLab, but there are all of these other aspects to it. A wiki is just a way of hosting the documentation associated with an application, like your user docs or your developer docs. So it's the green box, and in particular, it's the yellow box, because the green box is nothing new to us, really. That's really essentially what GitHub has been doing for us, but we're just using the GitLab platform instead. Some more what and why. Is there anything new here? Fully integrated with GitLab repo. Oh yeah, so and what I'm really talking about here is kind of the yellow box on the previous slide. What does the CI part of GitLab provide us with? Well, it's fully integrated with its repo side, as you might expect. It will allow us to version control. You see, what we're going to be doing now is we are going to be writing a build script, which is just going to be part of our source code. And just as we like to have version control of our source code, we will also have version control of our build scripts. Git hooks, that's all right. It's hosted for free, that's fine. Code and build scripts in the same repo, that's okay. That's all right, scalable, etc., etc. So that's just kind of marketing stuff there, really, to be honest. Right, so just some more terms now, and this, even though the heading on this slide is GitLab CI, but these terms actually apply to CI in general. So the main concepts of CI are pipelines, stages, and jobs. They're the kind of constructs that we need to create when we are trying to script our continuous integration. We want to create a pipeline, we want to create stages, and we want to create jobs. Structurally, this is how you need to look at a continuous integration script. It's made up of a pipeline. A pipeline consists of many stages, and a stage consists of many jobs, one or more, I suppose, really. And again, I'm kind of reinforcing this here. So I'm saying a pipeline is a group of jobs that get executed within a stage. All of the jobs in a stage are executed in parallel. And if any one of the jobs fails, then that stage is considered to have failed and the pipeline has failed. So when I was talking earlier on about, so a developer pushes an update to the central repository, and in our case now, they will be pushing the update to the central repository in GitLab. That event is going to trigger a rebuild of our application. And now what we can say is that it's going to trigger the execution of our CI pipeline. And the execution of the CI pipeline will involve executing all of the stages in that pipeline. And within each stage, it's going to execute every job within that stage. But if any job fails, then the entire pipeline execution is considered to have failed, i.e. our build failed. It may fail because the transpilation didn't work. It may fail because one of the linting tools found some errors in our code. It may be that a job that is running tests, one of the tests fails. Could be any one of those may cause the entire pipeline execution to be recorded as a failure. Now, in the case of using Git Lab, where we define our pipeline and our stages and our jobs is in a special file, and it's a YAML file. YAML is sort of, I'm not sure if you've heard of it before or not, but it's kind of a cleaner form of JSON. You can think of it like that. So it is a declarative syntax that we use to define our pipeline. The screenshot is just taken from GitLab. And so the way we can kind of read this now is I've written a pipeline for a project, and it looks like the pipeline has 3 stages in it. This is the way you can interpret this. And you can see here that I've ran the pipeline many times. It looked like this execution of the pipeline passed. However, this one failed. Where did it fail? If I look across here, it seemed to have failed in this stage here. And then we could actually drill down. You could hyperclick this part here, and we'll tell you exactly which job within that stage failed. But in terms of just the kind of high level interpretation of what I'm showing you here, I'm showing you a number of executions of a particular pipeline for a particular project. And we can see that the pipeline consists of 3 stages. Later on, I might add another stage, but for now it just has 3 stages. And each of these executions here happened as a result of me doing a git push to the GitLab repository that's associated with this CI pipeline. And these are the actual commits here. And this is what you will be doing in next week's lab. If we kind of look at the bottom of the screen here, really, so what's kind of happening, and again, I'm kind of repeating what I just said on the previous slide. So you're busily developing some code on your local machine. You push it up to GitLab as opposed to pushing it to GitHub. That's going to cause, because the repository in GitLab has that special script file that I mentioned. If I just go back, because it has this file within it, then GitLab knows it needs to run the pipeline associated with this project. And so what GitLab does is it finds an available server. It has a number of servers linked to it, and it executes the GitLab CI runner on that server. That's what I'm kind of talking about up here. This is kind of by way of background. The GitLab runner is a program written in Go, and it's kind of the platform on which it can execute your pipeline. So it finds a server, it starts up the GitLab runner on that server, and that GitLab runner then takes care of executing your pipeline. And that's kind of what's going on over here. I wouldn't worry too much about this particular slide, to be honest. It's just by way of background information, but that's what a GitLab runner is. It's the executable that runs your pipeline on a server, and the server is actually owned by GitLab or managed by GitLab itself, which means you don't have to worry about provisioning a server in order to run your CI/CD pipeline. So to get closer to what you will be doing in the lab, this screenshot is actually taken from the Movies app. And you can see this YAML file that I mentioned is just part of the code base really associated with the project, and it needs to be in the base folder of the project. And if we looked inside, this is our first look at what a CI/CD pipeline is scripted. What actually happens is, as well as Git Lab starting up this runner that I talked about in the previous slide, what the runner does then is it essentially installs a baseline operating system for your application, and you can control what the baseline operating system is. Technically, what it is a Docker image. I'm not sure if you're familiar with Docker or not, but that's what this line here is essentially telling the Git Lab runner. It's telling it to install this particular baseline operating system. And you needn't worry about, well, how did you come up with that? I'm just giving it to you. This baseline operating system is a Linux operating system, but it actually has Cypress, some Cypress required stuff already installed in it. It doesn't have Cypress installed in it, but it has some libraries that Cypress uses installed on it. That's fine. So the GitLab runner will find this image and load it onto the server machine that has been provisioned. What this part of the YAML file is describing, as you might have worked out, is it's actually describing the different stages that I have decided to, and these are completely arbitrary. You, as the developer, are in control of how many stages are in your pipeline, and you're completely in control of the name of them as well. They don't have to be called install, build, test. They are sensible names, but they can be called anything. So it looks like this particular pipeline has 3 stages. And if I look further down the YAML file, this is an example of how you implement a particular job on a stage. So I've decided I want a job and I've called it that, which is again completely arbitrary. I'm linking this job to the install stage, okay, because I have defined a stage called install. So this job is one of the jobs on the install stage. And here then is where I'm actually expressing what exactly I want to have done as part of this job. And we're familiar with this command. So it's just running the npm install. So it's going to install all of the node modules on top of the operating system that has already been provisioned for me. So these are just excerpts now. That's all I'm showing you, and you will be doing them in the lab, as I say. This is another example of a job. And again, I've purposefully written these in a way that makes sense to you. So this job I've called E2E tests. I'm linking the job to the test stage, this one here. And in this case, I want, first of all, I want to start my development server. Now, we won't be actually running the development server in our CI pipeline next week. That's actually considered bad practice, but I just thought I'd do it here because it would make sense to you. So we know what npm start does. It starts our development server. The @ symbol means we want to run it in background mode. If we left out that, then that's essentially going to hang our CI pipeline. So we're starting off our development server in background mode. We want that to happen first. And then once that happens, lo and behold, we're running our Cypress tests. So we can kind of relate to that. So these jobs here, I think this part of the YAML file is straightforward enough. You can kind of take this part as boilerplate. This is fairly self-explanatory what we're trying to code here. The jobs then are, well, the 2 examples that I've shown you are reasonably straightforward, but there are quite a lot of other parts to a job description than what I'm just showing you here. And that's what I'm showing you on this slide. There are all these other parts of a job description that you can potentially avail of. So a job might have a before script, which we actually saw an example of on the previous slide. Every job has to have a script section. The script section is where you document exactly what commands you want to have executed. And by the way, if I just go back to the previous slide, in both of these jobs, there was only one entry in the script section, but you could have a number of entries. So I would have another dash symbol and the next command that I want to have executed. By the way, so these are excerpts from a YAML file. There's one thing you have to be very careful about when you're coding YAML, and that is you've got to be very careful about the use of indentation and alignment. You know, these three here have to be aligned exactly. If I push this in one or two spaces, then as far as YAML is concerned, there's an error in that script file. So you just need to be careful about the indentation and alignment. But to go back to my jobs, in my jobs declaration, there are a number of sections. The before script, the script section. You may also have certain commands that you want to have executed after the scripts have executed. Maybe these might concerned with publishing metrics on some hosting service that the rest of the team can access. There's an artifact section. If one job generates some output and that output is used by another job, then the way we pass that output between jobs is using this artifacts section, and we will see that next week where that becomes useful. What's this one about? You know, you may want a job to only run when the user pushes an update to a particular branch in your repository. And we will also see that actually next week. So you've got that kind of flexibility available to you. Tags, I don't think I've ever used, so that's not of concern to us. We'll use the when one as well, but I'll skip over that for now. The three most important ones are these two here. So again, if I go back, a job really only simply consists of the various commands that you want to have executed at that particular part of the overall pipeline, as opposed to you typing these things in from the command line. We're actually scripting the execution of these commands. And that's it, really. It's all theory, I know, and that's the intention. So this is kind of summarizing everything that I've kind of talked my way through there. So in next week lab, we will take the movies fan app. Ideally, you need to have certainly part 3 of the series of labs completed, and we will implement CI predominantly. I don't think we'll do CD next week. We'll implement a CI pipeline for that project, and we'll be using the Git Lab service as our hosting service. And we'll also use Git Lab to implement or to execute the continuous integration process for us.